Hello friends, in today's session we'll solve questions from section A of Indian Economic Service General paper 1, and not all questions but the ones which involve mathematics calculation basically. Okay, so we'll do this question, then we'll do this question, and then we'll do this question. All right, in section A we'll do these three questions and we'll bring this village in a series. So all the questions that involves calculation will be answered. All right. So first, what is the MRS? MRS is the rate at which a consumer is willing to substitute one good for another while maintaining the same level of utility, right? So if you remember, then we had our MRS, marginal rate of substitution, that we studied in microeconomic, right? So we had your good here, x, and here y good, and this is your indifference curve. On this indifference curve, actually any point on this indifference curve is giving you the same satisfaction, correct? So if you feel there are 3 points a b c, from a to b, if you want to move from a to b, that means you are giving up some y for some x, right? So the rate at which the consumer is exchanging this y for x, so that is del y by del x. Okay, so this we know about MRS xy, correct? So it is the rate at which the consumer is willing to exchange the two goods. All right. So here we can see that MRS xy is equal to negative of mu x by mu y. So it is the same thing that we wrote as change in y divided by change in x and without the negative sign. So if we are writing this like this, then keep the negative sign. Now our utility function is x to the power alpha and y to the power beta. Now take the partial differentiation of this utility function with respect to x and y. So when you take the partial differentiation with respect to x, then it becomes the marginal utility of x. Then when you take the partial differentiation with respect to y of the utility function, you get muy, that is marginal utility of y. Now you just substitute these values and then you do some calculations here and you get the answer negative of alpha y beta into y by x. Okay, so this is your marginal rate of substitution when the utility function is like this. All right, now next is okay, next is, this was our question, q1 to the power alpha times q2 to the power beta. Okay, so what you do is you exactly put these values the way we solve it. Okay, so that was our utility function, and similarly you get this q1 is your q2, q1 is your x and y respectively, and find the partial derivative with respect to that. You will get this and put them in their position. So alpha by beta, negative alpha by beta divided by y by x. So in the place of y you can write q2 and in the place of x you can write q1. All right, so that is done for the part one question, number one question. Then Cobb Douglas production function is also like the same. So it is like a times l to the power alpha times k to the power beta, where q is the output, l is the labor input, and K is as usual capital input, and A is your total factor productivity, which explains the contribution of technology, or you can say that this is the residual solo residual, it is equal to solo residual. Alpha and beta are the output elasticities of labor and capital. Sometimes it is also known as the share of labor and capital. All right. So the share of labor and capital alpha plus beta, if it is equal to 1, then it is constant return to scale. If it is greater than 1, then it is increasing return to scale. If it is less than 1, then it is decreasing return to scale. Okay, there goes our. Then the next question, second question, that is first order derivative of a short run production function gives us the marginal product of labor. All right. The short run production function is the function of labor, if you remember, because the capital is fixed. All right. In the long run, both are variable, but in the short run, capital is fixed. So you can say that short run production function is a function of labor only. So if you are doing this, then the marginal production of labor that will give, if you take the first order derivative of this production function with respect to labor, then that will give us the marginal product of labor. And if it is positive, that means it is increasing at positive rate, and if it is declining, then it is declining, negative sign. If it is negative sign, then it is declining. And the second order derivative indicates the rate of change of the marginal product, whether it is increasing at the higher increasing rate or not. That will give us the second order, that is give you the rate of change. All right. And if this is becoming equal to 0, that means the marginal product is constant. Marginal product is constant, and you can expect that there is a point of inflection. There the shape of the marginal product curve will be changing. All right. Okay. Then the next is adjusted R square. We all know about the R square. R square measuring the proportion of variation that is explained by the model, means how R square measures the fitness of your model. And adjusted R square does the same thing, but it discounts for the number of predictors and sample size. If your n and k, number of parameters and the number of samples or sample size, that is. All right. So if you are having larger parameter, larger sample size, then adjusted R square will show you the change. If it is in the same direction as R square is changing, then it is okay. But if it is declining, so that means the additional variable that you have taken into account in the model, actually that is not a good fit for the model. You can drop that variable. Okay. So if you are including the unnecessary variables, overfitting the model, then adjusted R square will tell you whether it is relevant one or not. All right. So here the section 1 is completed. In the next video, we'll start with section 2. Thank you.